Blockchain platforms. Module 4. Permissioned blockchain platforms. Permissioned versus permissionless. Permissioned blockchains. Access to permissioned blockchains is controlled and thus requires the proper authorizations. Examples of permissioned blockchains are Hyperledger Fabric, Corda. Hyperledger. Let's study Hyperledger. What is Hyperledger? Hyperledger is an open source project hosted by the Linux Foundation. It focuses on developing blockchain frameworks, tools, and libraries. It is designed for private and permissioned networks. Hyperledger key features. The key features of Hyperledger are its modular architecture, which jointly with its pluggable consensus mechanism provide flexibility. Examples of consensus algorithms pluggable in Hyperledger are Solo for testing, the fault-tolerant Raft, and the now deprecated Zookeeper. Furthermore, Hyperledger has a rich set of APIs, Client System Development Kit, and Chaincodes API. This helps integrating with existing systems. Benefits of using Hyperledger. Some of the benefits of resorting to Hyperledger are enhanced privacy and security for enterprise applications. Hyperledger also provides high scalability for handling transactions at the enterprise level and support for permissioned networks, thus enabling access control. Finally, its open source community gives some trust on its continuous development. Popular frameworks in Hyperledger. As stated earlier, many frameworks are available under the Hyperledger designation. We now briefly present the most popular ones. Hyperledger Fabric. Hyperledger Fabric is a modular blockchain framework targeting enterprise use cases. Hyperledger Sawtooth. Besides its modularity, main highlight of Sawtooth is its dynamic consensus, allowing to switch consensus algorithms on the fly. Hyperledger Besu. Besu is a Java-written Ethereum client for permissioned networks. It implements the Ethereum Virtual Machine, EVM, and thus can run smart contracts written in Solidity. Hyperledger Indy. Hyperledger Indy is a distributed ledger designed for decentralized identity. It is used for building identity solutions focused on user privacy, security, and control over personal data. Examples include secure logins and trusted data exchange. Hyperledger Fabric. Let's give some attention to Hyperledger Fabric due to its wide usage for implementing blockchain-based solutions. What is Hyperledger Fabric? Hyperledger Fabric is designed for permissioned blockchain networks with modular architecture. It supports pluggable consensus mechanisms, Raft is the recommended one, and private transactions. Smart contracts are available through Chaincode and can be written in Java, Go, or Node.js to define business logic. Hyperledger Fabric is used in finance, supply chain, healthcare, and more. Key features of Hyperledger Fabric. Modularity is a prime characteristic of Hyperledger Fabric, as it provides a flexible architecture with interchangeable components. Its permissioned orientation allows for confidential transactions, all with performance, as it is optimized for high transactions throughput and low latency. It can also be scaled to accommodate the needs of large-scale enterprise applications. And as stated before, supports the development and execution of smart contracts, allowing automation of business processes. Hyperledger Fabric Architecture. Let's take a closer look at Hyperledger Fabric Architecture. The main components are peers, orderers, channels, chain code, and membership service providers. Peers are the basic elements that maintain the ledger and execute smart contracts, while orderers, as the name implies, ensure transaction ordering and finality. Channels are used for private communication between participants. Smart contracts are expressed through chain code to define the business rules. Finally, the membership service provider manage identities and permissions. Transaction flow in Hyperledger Fabric. So what's the flow of transactions under Hyperledger Fabric? First, a client application submits a transaction proposal to peers. The peers then simulate and endorse the transaction without updating the ledger. Thereafter, endorsed transactions are sent to the ordering service, which orders the transactions and packages them into blocks and delivers them to peers. Finally, peers validate the transactions and commit them to the ledger. Smart contracts in Hyperledger Fabric. In Hyperledger Fabric, smart contracts are called chain code and can be programmed in Go, Java, or Node.js. A smart contract defines the rules for modifying the ledger and needs to be installed and instantiated on peers before execution. Chain code uses endorsement policies to define transaction validation rules. Security and privacy in Hyperledger Fabric. So, what about security and privacy in Hyperledger Fabric? Well, access control and authentication is performed by the membership service manager, with sensitive data kept confidential through private collections. Access control lists allow to restrict permissions for users and applications. Finally, data integrity and confidentiality are provided by encryption and digital signatures. Use cases of Hyperledger Fabric. Hyperledger Fabric provides ledger-based solutions to diverse areas. Examples include supply chain management to deal with provenance tracking and logistics, healthcare to secure patient data, and interoperability between systems. In finance and banking, Hyperledger is part of solutions for cross-border payments, regulatory compliances, and trade finance. Some applications of Hyperledger Fabric also involves digital identity verification and electronic governance. Hyperledger Fabric. Consensus. Time to have a look at the consensus mechanisms of Hyperledger Fabric. First, it features a so-called orderer, which is responsible for performing transaction ordering, as Hyperledger relies on deterministic consensus algorithms and thus are not prone to forks at the blockchain network level. Conversely, Bitcoin and Ethereum are exposed to possible network forks, since they rely on probabilistic algorithms. In Hyperledger Fabric, any block validated by peers is guaranteed to be final and correct. Hyperledger Fabric. Orderer node. In Hyperledger Fabric, the orderer is responsible for ordering transactions and delivering them to peers. It ensures the consistency and finality of transactions across the network, organizing transaction into blocks for further validation. Challenges and future of Hyperledger Fabric. Challenges. Some challenges that needs to be addressed in Hyperledger Fabric relates to the complexity in deployment and configuration, as well as with performance bottlenecks that limit high transaction volume. Finally, at another level, the challenge is to overcome the adoption barriers in traditional industries. Future developments. Some planned future developments are to improve scalability solutions, to enhance interoperability with other blockchains, and last but not least, to promote advancements in security and privacy measures. Thank you for your attention.